Okay, well, I guess we'll begin. Oh, what's going on here? All right, okay. We'll look at today. We're going to move on, and now we'll start talking about getting data into R, scraping with RVest. We're going to start taking a look at packages within R that I don't know, maybe make our life better. So I feel like we've covered a lot of the nitty-gritty of the functions and environments and programming and all of that stuff with R, and getting an understanding of kind of the inner workings of the language. And now we'll start using packages where people have written some high-quality code that does some things very well. Okay, so here we're going to take a look at importing data into R and scraping with RVest. Okay, we have some basic commands such as scan, which will basically just scan in any file that you give it. Okay, and then read line you've probably used in your tic-tac-toe, which allows you prompts the user to enter some data that way. And then I'm pretty sure you've probably used read.csv somewhere in stats 20 where you're reading in a CSV file. So this is probably a very common way to get data into R. Okay. I encourage that you install the package reader. Okay, reader. This is kind of, I would say it's superior to regular old read.csv, read_CSV. This would be, this is a package written by Hadley Wickham, and it just gives you generally a better performance than read.csv. Okay, so these are all good ones. Read_Excel is for importing Excel files, or if you're going to import SAS, SAS, SPSS, or Stata files, you have Haven, or even data.table can read in some large tables. So in a DataFest type situation, library data table and an FRead for fast reading will help you get in very massive files. So these are all really good packages. You can look up how to use them in their respective help files. No problem there. Here's a couple links to just how to use them. So the vignettes. So a lot of times when you're looking up our package, you'll see a reference manual. The reference manual is just like kind of the package functions and maybe some examples of those things. Generally, if they have a vignette available, the vignette will serve as a useful guide on exactly how the package can be used. So I definitely encourage checking out the vignette for data.table. There's also a webinar, which is like a kind of like this. Basically, the guy is recording his screen on using these packages, and it's also good. Okay. There's also a package called Downloader. Right? Downloader implements the download.file function. So base R has a download.file function, but it doesn't work if you're giving it a link that's HTTPS. Okay, so right. So if you're on anything where it's secure versus a regular HTTP link. So download.file will work for plain non-secure things, whereas library downloader will have kind of the functions to kind of form a secure link and allow you to download files. And so so sometimes there will be files online that you just want to download, and you can do that within a script, right? So so sometimes you want to write a script and send it to somebody for them to run, and And if you include the commands for downloading a file onto the computer, that saves on the step. You don't have to say, here's the script that you're going to run, but before you run this, make sure you go to this website, download this file, and store it into this folder, and then run the script. Okay? Because that's anytime you have additional steps, it's less likely they're going to do it, right? So if you just have one single thing where it includes the downloading of the file and all of that, that just makes life easier. Okay, so that's another way of kind of getting your data into R. Anytime you handle date and time information in R, it can get really tedious. Okay, and so here is a package called Lubridate, and that makes handling date and time information a lot easier than using just the regular base R functions. You can handle date and time information with base R, but this one makes it a lot easier. Okay, so for example, if we load up library Lubridate, you can have dates written in any of these three formats. 6th of August 2005, January 15th 99, 12/15 2001, and all you have to say is kind of like, this date comes in day, month, year format. This one would be month, day, year, and this one would be month, day, year, and it understands that. Okay, so actually it looks like I ran out of space on the thing, but let me load up library. So here I've got these three dates as strings, and if I just say day, month, year for the first string, it understands that. I say month, day, year for the second string, and it understands that. And even though the third string is completely in a different format, because it's just month, day, year, I call the same command, month, day, year, on this string, and it also understands that. Okay, which is, before the days of Lubridate, this kind of stuff was really tedious. Okay, you had to tell R the specific date format. So here, for this, to say we've got a date as a string where it's the day, the month, and the year, we have to say %D, and then %B for the month, and then %Y for the year, for it to understand. Okay, and then over here where I have the month, the day, comma, and the year, I have to specify that the date format is like this, and the formatting has to match exactly, otherwise the conversion will fail. Right? So if you don't have the spaces, or if you leave out the comma, or if you use a lowercase b rather than a capital B or something like that, these things fall apart and break. And again, for here, because over here we had the month written out in words, we had to use %B. Over here we have the month written as a number, so we have to use %M. And so you had to remember all of these things for handling strings written as dates. Okay, so don't worry about any of this, because basically the whole point of this slide is just to say it was really frustrating before Lubridate came along, and now Lubridate makes our life easier. So if you're going to handle any kind of date information, make sure to use the Lubridate package. All right, is that okay? All right, and then I guess kind of the last thing, then we'll spend the rest of today covering, will be package Arvest. Okay, so Arvest is kind of like harvesting data from the web, or web scraping, and so this allows us to go to web pages and download data. And this is still a useful thing, maybe less so because a lot of websites now have links to their data, either through some kind of XML archive or JSON or something like that. But here we've got Arvest, and this allows us to pull data from, kind of references and things like that. So you would load up library rvest in R. And then in here we'll try this out, okay? Let me, do I need, so we'll load this up, okay. All right, the way rvest works is, it uses something called the selector gadget, okay? And selector gadget is, if you go to the website, there's kind of like you're just gonna add this bookmark to your bookmarks bar, and then it allows you to select things using CSS selectors. So a lot of web pages will designate kind of headings and different pieces using a CSS tag to kind of say, like, everything with this tag is a heading, therefore in my style guide, if you see a heading, we want it to make it big print and bold or something like that. And everything with that tag that says it's a heading will receive big print and bold. The selector gadget takes advantage of those tags and uses it to then get some information. Okay. So I'll do a demo of rvest in a moment here. Okay. And you can kind of read up on the vignette and the selector pipe, okay? The rvest, and in the future we're going to cover dplyr and all of that, they use something called a pipe, okay? And a pipe, what it does, it looks like this. It's kind of this percent greater than percent, so it kind of looks like an arrow. We'll take the result of a function and pipe it into the next function. All right, and you can get a shortcut once you load up one of these things. You can shortcut the pipe by doing Control-Shift-M, so you don't have to type in percent greater than percent. You can just do Control-Shift-M, and it will insert a pipe into your code. So let me just kind of explain why we might enjoy or appreciate the usage of a pipe. Okay. So let's say you wanted to do the following. You want to take all of the integers from 1 to 1,000, okay? You want to select those that are divisible by 3, and those that are less than 200 or greater than 800, and find the square root of all of those values, okay? So we basically want all numbers divisible by 3 that are less than 200, all numbers divisible by 3 between 800 and 1,000, and then find the square root of those values in total. Okay, so this is just a simple example. All right, the regular way we would have to do, if we wanted it in one line of code, I could do standard deviation of, we're going to subset the values 1 through 1,000 based on the rule, 1 through 1,000 has to be divisible by 3, and then do a subset subset that further by saying it has to be divisible by 3 and less than 200, or also greater than 800, okay? And you have all of these nested subsets, and this would be very difficult. If you saw this and you didn't see this, it would be difficult to understand that this code corresponds to this, right? If we wanted to do it in one line, this is what it would have to look like, okay? So another way of doing this, and then it would be to go step by step, okay? So we'd say A is first going to be the integers 1 through 1,000. We're going to take A, we're going to subset A based on A has to be divisible by 3, and we're going to store that as B. And then we would subset B using the rule B is less than 200 or B is greater than 800 and store that as C, and then we would take the standard deviation of C. This is a lot more clear in terms of what it is doing, right? Except now to do this, we've had to create a bunch of, we had to take A, then create B based off of that, then create C based off of that, and then take the standard deviation, which is fine. And I would say this is probably much better than this because you gain clarity versus this where you did succeed to do it in one line of code at the expense of having no idea what's going on, right? So piping basically allows us to do things this way without the need for creating each of these things. We can say, all right, we're going to take 1/1000 and then we're going to just pipe it into this function, okay? So with pipes, we would say take 1/1000 and then throw it into the function subset, okay? Dot is kind of a stand-in for the previous result. So here we're going to subset this and say that it has to be divisible by 3. And then we take that result and then we pipe it into the next subset, which is it has to be less than 200 or greater than 800. And then we pipe that into the standard deviation function. And it finishes there. Okay? So pipes allow us to have this without the need for creating a bunch of intermediary storage values in between. Okay, and so we'll see the usage of the pipe in our use of the Arvest demo. Okay, so here we'll get into Arvest here, and we'll see pipes show up a lot when we're doing dplyr next week. Okay, and I'm very excited about that. I hope you guys are too. So we'll see. Okay. Okay, so what we're going to do is we're going to go to this website. This is the movie page for the Lego Movie at IMDb. Okay. And have you guys seen the Lego Batman movie? It's excellent. Okay. Well, if you like Lego and if you like Batman, and if you like Will Arnett and Michael Cera, and well, anyway, all right. It hit all the check boxes for me, so I loved it. Okay. All right. So here is the Lego Movie, and let's say we want to extract a piece of information out of this website. Okay. So what I'm going to do is I'm going to use the selector gadget to figure out which tag it is that I want to use. So let me just kind of check what exactly I'm going to be doing. And what we want to do is we're going to try to select the movie rating here. Scrape the website for the movie rating. Okay, so what I'm going to do is I'm going to click selector gadget. So once I'm at the web page, I click selector gadget. And again, selector gadget, you have to take this thing and you just drag it to your bookmarks bar, all right? And the shortcut's actually this crazy JavaScript thing, but it doesn't matter. You just, now that you're at the web page that you like, you click this thing, and it loads up selector gadget here. It puts this thing down at the bottom, and you just kind of hover over stuff, and you say, I want to get this number, 7.8. This is the star rating for the Lego Movie. Okay, so I click that, and now we see a whole bunch of stuff highlighted in yellow, right? And so, yes, I want this thing, but I don't, oops, I accidentally clicked something. Sorry. So I want this 7.8, but I don't want all of this other stuff. So I'm going to just click something that's yellow that I don't want. I don't want this thing here. So I'm going to click that, okay? And so I click that, that shows up in red, and so we see that pretty much almost everything else that was yellow disappeared. However, we see clear, and there's a number 3 here, which means 3 things have been selected. And I really just want 1. And if I look carefully, I can see, oh, this number 10, that's also yellow. So I'm going to click that, okay? And then so now only 7.8 is green here. And it tells me that the way I select this is by using the tag strong span, okay? So apparently this is the only tag thing in the site that uses the tags strong and span. So I can just kind of click this and click copy there, and that's it. Okay. If I wanted to select something else, like I wanted to select the title, the Lego Movie, then I would click. Oh, maybe I can't select it. This is selecting the entire thing, but I don't. Okay, that was unsuccessful. All right, for some reason I can't select just the words the Lego Movie, but I can select something else like or that. So, you know, pretty much anything you click, it's gonna like highlight in green. Okay, so now I want this this thing, summary text, okay? And it says that's the only thing there that's called summary text. Or if I want to select, here I can select Will Arnett's name, and but maybe I don't want the box, so here I just have the text, okay? And this looks reasonable. Oh, Jonah Hill was Green Lantern in this? I didn't know that. Okay, so so we have that. Okay, so anyway, we said we're going to do strong span. Okay, so to get this into R, using RVest, we're going to use the command read_HTML. This takes the website for the Lego Movie, and it takes the HTML, it reads that, and it loads that into something called Lego Movie. And it takes a second to do it because it's got to go to the internet. And this is all it says. Lego Movie is a list of 2, and the structure of this is actually like, I don't really know because the attribute is really crazy, but there we go. All right, so this is it. And what we want to do is we want to extract the text that is stored in the tag for this number, 7.8. So I'm going to say, we want to do is we want to store this value as rating. So we're going to take Lego Movie, which is all of the HTML from that website, and we're going to pipe it into the command HTML nodes. Okay, HTML nodes takes the HTML, and it's going to look for any node or any tag that has strong span. So in this case, I take that thing and I pipe it into HTML nodes, and this will return the XML tag that has that's within strong and span. Okay, and so this is what we have. What we want to do then is we want to extract the text 7.8. We don't need this other stuff. So then we take this result and we pipe it into HTML text. So when I do that, it returns me 7.8. And then lastly, we want to turn this into a numeric value, so I pipe that into as.numeric. Okay? And then finally, we want to save all of this into rating, so we do rating is basically equal to the result of all of this. So I do this, and boom. The rating I now have as a value that I can use in R, 7.8. Okay? We can do this. It doesn't have to be just single things. It can actually return a vector, okay? And so if we're at this web page for the Lego Movie, I can click, again, selector gadget, and here I'll hover over the name, and so here, apparently this is the tag I'm going to use, item prop, okay? And this will be what we want, okay? All right, apparently when I did this last, it was a little bit different, but I think it should still work. So here, I'm taking the page Lego Movie, and then I guess when I did it last time, the HTML CS selector gadget gave me this tag, title cast item prop span. But we can do it, and again, we want to extract the text. So I'll try using what I did. And so when I do this, it pulls out all of these names, okay? I think, here, let me just try Lego Movie, and we're going to try HTML_nodes. and I'll do kind of what we had here, and we'll just see if this also works. Yeah, so this also works. So sometimes when you use selector gadget, based on, I guess, based on the order in which you click things, I don't know how this works, but okay, so it's still doing it this way, doing item prop, but sometimes the selector gadget might return a different set of tags that basically highlights the same thing. So here now I have a list of the people on that cast section of the web page. Yeah, question.
So a lot of websites does not allow us to actually get information from the website. So what's the reason of that? Is it because they didn't set any tag for any specific
like what website are you thinking of?
I don't know exactly the name, but I think a lot of websites does not allow you to actually get information directly from the text they're putting in the website.
So if it's a HTML page,
Yeah.
if it gets rendered as an HTML page, then this thing can do it. Okay. If it's not an HTML page, then we'll experience trouble. But basically, if on the website you can right-click and say View Page Source, and you have an HTML document, basically it's just crawling, it's parsing all of this out into something that it can extract. So somewhere in here we have the name Jonah Hill, and you know, this does have the thing item prop, okay, and that's kind of where it's getting that thing, right? And so you know, along with Todd Hansen, Morgan Freeman, and Dave Franco. So these are all those show up in the HTML, and that's all this thing is doing. So if the website does it, then we can extract it. Okay, we could even pull out things like if we wanted to pull out some attribute. Okay, so here we've been using HTML text, but you know, if we look at the page source and we're looking for the kind of the image for you know, one of the pictures here, we can use the attribute src kind of for which is how we find the link for the poster. Okay, and then so here, oh, it didn't find it. Maybe maybe the tag has changed, but let's see. Can I select this thing? And don't want that. Okay, so well, I'll just try this. It says there's two things selected, so it might pull out two different things here. Okay, so it's returning me two URLs, and so if I were to use one of these URLs, I think this will return, you know, the URL of the image, and then I could throw that into download.file or something, or not download file, download, and download, you know, images and stuff like that. Okay, and again, you can use it for anything else. You know, the IMDb page also has user reviews. Oh, did I write this one? No. So a reminder of how fun Lego can be. You know, 10 stars and whatnot. All right. So here, this is what the user wrote. And that's what they've done. Okay. Okay. So we can use Arvest to go to a web page and then scrape the information from the web page. Is that okay? All right. This is I'm going to demo something here, which I think this is totally amazing, just like everything in this class. But we can create an automated browser to then go on the web page and pull out information, okay, and follow links. So let's say you suddenly became obsessed with the Lego Movie, and you were like, I loved every voice I heard, and I want to know what other movies they've been in, right? So you're like, I'm gonna find out what else Will Arnett has been in. So you're gonna click Will Arnett's page, and it takes you to his IMDb page, and you're like, oh no way, he's BoJack Horseman, and he also is, and they're making a Nut Job sequel, and then you say, okay, well that was really exciting, and let's find out about Elizabeth Banks. And Elizabeth Banks is, they're going to be in Pitch Perfect 3, the final segment of the trilogy, and she's also in Curb Your Enthusiasm. So that's and you can go through, right? And this is how you spend 8 hours on IMDb, just clicking through links. But you can say, well, I have R, and I want R to do my work for me. So what we're going to do now is we're going to create a session. And a session is basically like every time you go on a website, your browser establishes a session and says, hey, I'm browsing your website, and it like gives you cookies and all sorts of stuff, right? So we're going to start a session at the IMDb webpage, okay? And we're going to just put this session into the object S here to give us our session. Okay, so I've done that. S is now a session, and I can say, you know what, I want the browser to follow the link that says Will Arnett, okay? And so I can do this, and I can say, starting with the session, we're going to pipe into follow the link titled Will Arnett, okay? So if there's multiple, if there are like multiple links that say Will Arnett, this just goes to the first one that says Will Arnett. But you're going to say follow the link that says Will Arnett, and then from the resulting page where you end up, read the HTML. Okay, so here I can say S follow Will Arnett, and the result, store that into Will page, and you can say it's going to navigate to Will Arnett's page, right? And then so now it has followed this page, and it has loaded this up, and now that we have stored this, we can then use selector gadget on this part and say like, oh, I want to find out kind of the names of the other titles that he's been in. And so it's gonna, here I'm selecting the tags B and A, okay? So apparently he's been in a lot of stuff, and then I can use Rvest to kind of pull those things out. So I can say from the Will underscore page, I can pipe and say we got read HTML, and so we can do HTML underscore nodes BA, and then pipe that into HTML underscore text, and then we'll see what we have, and it pulls out all of that thing from Will's page, right? Huh? So, okay, so what we can do then is rather than just doing this individually for Will Arnett, we can say, you know what, I want this to go through and do it for everybody who is in, or not everybody, but at least these first 15 people who were in the Lego movie, right? So we've already, earlier on, we created the list cast, right? So here, or not the list, the vector cast, which has the names of all of the actors: Will Arnett, Elizabeth Banks, Craig Berry. You know, we have these names here, and you know the links are there exactly. So what I'm going to do is I'm going to create a place called cast underscore movies, and make an empty list. And for each page, what we're going to do is we're going to start in our session, follow the link that's called Will Arnett or Elizabeth Banks or Craig Berry. We're going to follow that link and read in the HTML, okay? Much like I did for Will Arnett. And then we're going to pull out the movies or the titles that they've been in. And from the actor page, we said the titles that they were in uses the node B and A. Okay, that's the tag to select that. We're going to extract the text, and because some of them have been in so many, we're going to pull just the top 10. Is that okay? So that's what I've got here. Are you guys able to follow these pipes and stuff? And we're going to store this into cast_movies double bracket I. So this is going to create basically a train car in I, and we're going to store it into kind of the slot movies here. And then we're also not just the name of the movies, but we'll pull out kind of the years of these projects here. And so you know, using selector gadget, we can say, all right, how do I select these years? And oh, well, that was easy. All I had to do was click year column. Okay, so we'll do that, or I guess filmography year column. That's what I have, and we're going to just pull out, you know, the first 10. Here I says string extract, basically the first 4 digits. You know, I could just as well leave this off as well. Okay, so I've got this part, and that's going to store into years, and then we're also going to take name and just take the actor's name and repeat what it is. So notice our for loop is just going to go through the names. It's not it's for I and cast 1 through 3. So if I do cast 1 through 3, it's actually taking the names Will Arnett, Elizabeth Banks, and Craig Berry, rather than doing you know, subsetting them into 1, 2, and 3 or something like that. Okay, so I'm going to do this, and it runs, and it does what I asked it to do, and it went to each of those 3 pages there. Okay, and so I can say, all right, what does this list look like? And it looks just like I would expect, which is here it has the movies, it's got the years and the name. Okay, and then it created another list called Elizabeth Banks, and it's got her movies, the years, and the name. Okay, and something like that. All right. So we see that we have /n, the number, and /n. So that's why I put in kind of the this text that says string extract here. Okay, and then, you know, instead of the top 3, I could do like the top 6, and then this will just further expand, and it will go through the first 6 names on the cast list here. Okay, so it's following each of these things. So it'll end at David Burrows right there, and then we can, you know, see the structure, or I guess I went through Anthony Daniels, David Burrows. Okay, and looking at just the first one, this is for Will Arnett. We have movies, years, and name. Okay, right, and if we ask for the structure of cast_movies, it's nested lists, right? It's the top thing at the top level. It's a little list of 6. Will Arnett itself is a list of 3. Elizabeth Banks itself is a list of 3, and each of these actors themselves is a list of 3. Okay, and then I have there's one function called rbindList from package data frame that will then, because all of these lists are of the same length, and each thing within the list themselves are of the same length, we can do this and make a data frame out of it. And here I've created a data frame of kind of each of these actors. So they've got, you know, and so this was generated by starting at the IMDb page, following the link, and then extracting this information, and then going back, following the link on the next to the next link, extracting that information, and putting that in here. Okay, so this is I I feel like this is kind of impressive as far as what R is able to do. It's able to start at a page and then follow links and then pull the information from the page that follows. And you can and use this to basically start scraping the web, and you can start creating a thing. Now, one of the you have to be careful because some websites don't like robots, okay? And they don't like people scraping their site. And so generally, you know, it's bad manners to send like 1,000 requests to a website and within a few minutes, okay? So, you know, always play nicely. It's generally a good idea to make sure your code works using a small loop like for 1 through 3 or something. And if it works for if it works for 3 and then you want to do like all 200, then you can do that. But don't test it out and do like for I and 1 through 200 and because if they have any kind of security protocols on their server, then they might say this person's trying to attack us here, and then they might block your IP. Okay, and I don't know how it would work for a university, but something like that. Yes, question.
So I think for loop is not very efficient in R, right? Is there any other way I can use it and apply accomplish this?
Yeah. Okay. So for loop, you're right. A for loop is not very efficient, but the not very efficient part here is the fact that you're going to the internet to access the thing. So I would say it's totally okay that we're building a for loop. We don't really have a way to because you can't. There's no command that says apply following 50 links all at once and doing that, right? The only way you can do that is follow the link one at a time and pulling that thing up. So you're gonna have to do a for loop that goes through the links individually. We can't suddenly open up 50 browser windows all at the same time, follow 50 links, and then pull that information off. Okay, so we'll end here for today. I hope you guys have a great weekend, and we'll see you guys on Monday. Good luck for the last few hours of your homework, I guess.